In this video, I'm going to solve a question based on quadrilateral, and the property on which it is based on is midpoint theorem. Theorem says that in a triangle, if you join the midpoints of two sides, let's say P being the midpoint of AB and say Q being the midpoint of AC, then the property says that this length PQ will be parallel to this length PQ will be parallel to BC, that is the third side, and the length of PQ will be half of BC. That is what the property called midpoint theorem based on which this question. Now, as I can see in the question is given that P, Q, R, S are the midpoints of the sides of this triangle ABC. Definitely P will be the midpoint of AB, Q being the midpoint of BC, and so on. In the first part, what we have to prove is SR, this length SR is parallel to, this is SR parallel to AC, right? And we also have to prove that this length SR is half of this length AC. So we are going to use the midpoint theorem. Let's first consider the triangle ADC. Why so? Because we are going to apply midpoint theorem in this triangle. So we'll start with this triangle. We have triangle ADC, and you can write SR is S and R are the midpoints of this side AD and DC. Therefore, SR is parallel to AC, and we can also say that SR is equal to half of AC. And we can mark this as equation 1. And the property you will be writing, or the reason in fact, is this. That is, you can simply write midpoint theorem also, or may explain this whole line. Now, this is what we had to prove in the first part, and we proved. When we see the next part, it says prove that PQ. What we have to prove here is this length PQ is equal to SR, right? So for that, what we are going to do is consider this triangle. And then over here, we are going to prove PQ is equal to half AC. So let's say if I consider triangle, this time it is ABC, P being the midpoint of AB and Q being the midpoint of BC. So we can say over here that PQ, or you can write in the next line, PQ is parallel to AC and PQ is equal to half of AC. And I'm marking this as equation 2. Now, when you see the equation 1 and 2, you can figure out that this length PQ and SR, right? This is equal to half of AC. So I'm talking about the equation 1 and 2. You can see here, both PQ and SR is equal to half of AC. Further, you can also see that this SR as well as PQ is parallel to the same side, that is, or the same line AC. So two lines which are parallel to the same line are parallel to each other. Now from 1 and 2, what we can write that PQ is parallel to SR and PQ is equal to SR. Although in the second part, you'll see that we just need to prove this part, that is PQ is equal to SR. But in addition to this, I also wrote this. The reason here, because in the next part, we have to prove this figure, a parallelogram. We need to prove this figure, PQRS, this quadrilateral, a parallelogram. And as you must be knowing that when you prove the same pair of opposite sides equal and parallel, if you prove the same pair of opposite side equal as well as parallel, then it becomes a parallelogram. And that is the reason why I wrote this. So we can say from these 2 points, right, PQRS is a parallelogram. We're writing PQRS is a parallelogram. And the reason, as the same pair of opposite sides, same pair of opposite sides are equal and parallel, right? And that's why we say it's a parallelogram.